Okay, good morning everyone and happy Sunday. This is Mr. Nunez and I wanted to show you guys all how to do problem number 6 on page 13 of the unit guide. So the problem gives us a data table and it's showing the acceleration of various masses similar to the chicken problem we saw in class. And the key here is that it's as the same net force is applied to each mass. What it wants us to do is make a claim about whether or not the data shows an inversely proportional relationship, and then we need to justify it using evidence and reasoning. So from now on, whenever we see these types of problems, claim, evidence, reasoning, there's a very specific way that we're going to approach this. Okay, we call it a CER. Ideally, you should never need more than 1 or 2 sentences for each part of these. So if you're somebody that likes to write long prose when solving problems, this is not the time to do that. Okay. So first thing is we need to know what an inversely proportional relationship is. And hopefully you remember from class that as your x variable goes up, your y variable goes down by the same factor. So when this is doubled, this should be divided by the same amount, and sure enough it is. 2 goes to 4, 16 goes to 8. When 4 is doubled to 8, 8 is divided by 2 to 4. So the first thing I have to do is make a claim about this relationship, and my claim is going to be the data shows an inversely proportional relationship between mass and acceleration for a constant force. Now this is definitely a high-level way to write this type of claim. I'm using some very scientific terms here, such as for a constant force. If you can essentially fit your claim into something that looks like this, you're guaranteed full points every time. A good claim always takes a firm stand on what's going on in the data. So for me, I said the data shows an inversely proportional relationship. Students often like to use the word change. So they might say something like the data shows a change in acceleration with mass. Change is not very helpful because this is obviously a change. Instead, we want to know what kind of change, and so in this case the change is an inversely proportional change. Now we need to talk about evidence. Evidence should come directly from the table. So what I would say is as mass doubles from 2 kilograms to 4 kilograms, the acceleration is halved from 16 meters per second squared to 8 meters per second squared. Notice, not only am I using evidence from the table, but I'm actually pulling numbers to prove my point. You do not get the evidence point unless you are providing numbers from your table. Okay? And so to round it all out, we need reasoning. Now this is often the hardest point to get because reasoning needs to take either a law or a rule and apply it to the situation at hand. So what I would say is inversely proportional relationships show that as x increases by a certain amount, y decreases by the same amount. So this is where it's important to study, because if you didn't remember what an inversely proportional relationship is, you can't actually write this sentence. Now, this isn't enough to get me the point. Now I need to take this reasoning and apply it back to my original claim. So because mass doubles, and I'm going to help my reader out and put in parentheses times 2. And acceleration is halved, again parentheses divided by 2. This is an inversely proportional relationship. So this is just one tutorial over CERs. We're going to do them a lot this year. But to recap, the claim needs to answer the question without using vague words like change. The evidence needs to come directly from the table and actually list out the numbers. And the reasoning needs to use something that we learned in class to actually apply the vocabulary to your claim and to your evidence. Hopefully this helped. Have a great rest of your weekend. I'll see you all on Monday.